Hey guys, welcome to my Capstone one. This I'll pick a project of analyze and visualize the data of parking lots in Toronto. Um, the goal is to see which parking space is prime for redevelopment, um, which means to turn into housing or green spaces or community spaces, etc. The rationale for this project is because we know that housing shortage, urban heat effect, stormwater runoff, and other urban issues are um, uh, uh, prompt us to rethink the purpose of these often underused concrete surfaces. For mapping purposes, I use one visualization file containing the delineating polygons of the city of Toronto's neighborhood boundaries, and another file containing the detailed information about parking lots in Toronto, including the number of parking spaces, type of access, and their GPS coordinates. The first step is importing the data and prepare data for analysis. So we can see that, in the column names, there's a lot of spaces in the column names. So I use to clean it up by replacing the spaces with like empty strings, so that it's easier to refer to these columns later. Also, I noticed in the name of the parking lot, and the last word says about like what type of parking lots there are. So maybe park, building grounds, gardens, or the sport complex, or etc. So I also use regex, which is a regular expression um, to extract the last words of the the um, the name, and then add it to the column at the end here. So you can see type, building grounds, park, etc. And coming next to exploratory and data analysis, so I do the normal things like the distribution, basic statistics like count, means, marks, um, etc. And I also inquire about the info of a data frame to see how many no data rows there are, and then for some visualizations, I use some matplotlib to visualize some basic like column chart, bar chart of parking spaces by type, um, by access kind as well. Yeah. Um, I have pie chart, column chart. What else? Yeah, and histogram showing the distributions of parking spaces. And the last steps is for me is to visualize them on a map. So first of all, I noticed like from the step above that there are rows with like NaN values in the GIS like coordinate. So those we cannot map them. So I drop the null values in those column only. So after doing the check and see there's null values in the GIS coordinate columns. But still there are null values in the other columns, but this is fine because we still can map them. And then other things I noticed as well is like the GIS coordinates in the latitude and longitude, like they're like combined together. So I also use a regular expression to split the column into two columns, like longitude and latitude, in order for the map to map it. And so in the first attempt, I noticed like there are more than 400 rows in the dataset, which is very large, and the map didn't render correctly. So I filter out the large, like, basically the biggest lots that is worth looking into, and by applying a quantile method. So like say I filter out like only the 50% biggest parking lot, and then still this is a lot of information. So Bokeh only work like when there's less than a few dozen rows to map. So yeah, here I use clustering. So I cluster the bubble, the parking lot that are closest together, like geographically, into clusters, to reduce the number of clusters in total, like in order for the map to show. And yeah, so I give access type, different kind of color. I give the size of the bubble, as in the capacity of parking space. Um, yeah, and then after mapping, this is, oh sorry guys, here down here. So this is how it looks. So yeah, you have a bokeh map, like totally interactable. And then you can zoom in and out. So you can see these are the cluster of the parking lot and the distribution on the map. Yeah, so as I said before, there are more than 400 roles, and they cannot be visualized all on the map, so we have to put into some cluster. But if you guys are still interested in like looking at how they are, like the parking lots are distributed on the map, or I have to put them into a separate GIS application called ArcGIS, S3 ArcGIS, with the industry standard in mapping, and or I printed out like this screenshot. So you can see this is the 440 rows representing all the parking lots in Toronto in the data set. Yeah, and well, you can see there's a lot of like along the green spaces along the Toronto Ravine system, which is consistent with the early data analysis. We did like earlier. It shows that like there are a lot of parking spaces like around the parks area in the city. Yeah. So in overall, this analysis is very simple, rudimentary, but I think this is a good step, like in first like visualization, like all the parking spaces we have in the city. And the next step in this project, I think, is like also to map these spaces with things like demographic, population density, proximity to public transit, and in need housing, etc., zoning laws, in order to determine which parking lot should be put into better use, like like turn into housing or like green spaces. Yeah, so I'm very excited to for part 2 and 3 of this project, and thanks you guys for listening in.